So now for question 4, the last one, I'm being told to find where the function, this function, has a minimum and a maximum value. So now the minimum and the maximum value occurs when the derivative is 0, because the derivative is the gradient. And so for this one, it's a function of both x and y. So then we're going to use partial differentiation to find this one, and then once we find our value, we're going to try it for, I'm sure you've gone through the way of finding minimum and maximum by partial differentiation. So the first one that you must check out, the first one that you must find here is partial dz over partial dx. This one will be equal to 3x to the power 2. This one will be a constant, and then we'll have negative minus this y will be a constant, so we'll have 2y, since y is a constant, so the x variable will go out. Then partial dz over partial dy is equal to 2y minus 2x. So then when we equate them to 0, we are going to find the points at which we have a maximum or a minimum value. So then let's solve this simultaneously. So then we're going to solve this equation simultaneously. We're going to have 3x squared minus 2y being equal to 0, dz then 2y minus 2x also being equal to 0. So you're going to take these to the other side. So you're going to have 2y is equal to 2x, divide both sides by 2. You're going to have y being equal to x. And then now for this one here, you're going to replace back. So you're going to have 3x squared minus 2. Where there is y, you put x equal to 0. So then you factor out the x. Then you're going to have a 3x minus 2 is equal to 0. So here x is equal to 0, and then 3x minus 2 is equal to 0. When the 2 goes the other side, 3x is equal to 2. Divide both sides by 3 by 3. X is equal to 2 over 3. So then this is 0, and this is the other point. So now you try to when you try to plug it in there, you're going to find that where x is 2 over 3, y will also be 2 over 3, because y is equal to x. So the first point we have is 0, 0. Then the other point that we have is 2, 3, 2 over 3, 2 over 3. And so these are the 2 points. We just have to determine whether they are maximum or minimum. So now we are given certain rules which say when rt minus s squared is greater than 0, we are going to have a maximum or a minimum value. So we're going to have a maximum value when r is less than 0, and then we're going to have a minimum when r is greater than 0. That is when r is positive. So now, what is t, what is r, what is s? So I like to put them in the order of in the order that's alphabetical. That's r, s, t, like r, s, t, u, v, w, and then rt is equal to the partial d2 dz over partial dx squared, and then s is equal to the combination of what we are going to find here and what we are going to find there. So t is given by partial d squared z over partial dy squared, and then they follow alphabetically. So this one will be given by partial d squared z over partial dx over partial and partial dy. So now our r is the second partial differentiation of x. So here we are going to have 6x, r is 6x, and then s is equal to, s will be the either of the two, but then you're going to differentiate them with respect to the other variable. So partial dz by partial dy of this one, you're going to have -2 and then partial dz over partial dy of this one, you're going to have those are the squared, so partial dz squared over partial dy squared, you're going to have this one will be treated as a constant. You're going to have 2, so t is equal to 2. So now you've found your r, you found your s, and you've also found your t. So now let's start checking. For this one, we have our, for this point we have our r. It's not greater than 0, it's not less than 0, it's not greater than 0, it's equal to 0. So now when r, I forgot to put this one here, when r is equal to 0, we're going to have a saddle point, so meaning it's not a minimum or a maximum value. So this point is not a stationary point. You can say there is no extreme value there, and thus you can conclude that this one here is going to be a saddle point, where this one is going to be a saddle point. So you can say saddle point, no extreme value. Yeah. So then we are going to check out this one. So I'm going to say r is definitely greater than 0. Where when you put your x there, r is greater than 0, because you're going to have 6, 2 over 3. This one will cancel, then you're going to have 4, and thus you can conclude that this one here is going to be a maximum point, since r t minus this one is, that's r by the way, r is going to give us this one, then rt. So let's say rt minus s squared, we are going to find the value. So our r is 6s, our t is 2, so this one will give us a 12. Then you can put a minus sign there, then our s will be equal to 2 to the power 2. So then when you put the value there, you are going to have 12, 2 over 3 minus 4. So when you cancel this one, you're going to have 3 there. 3 times 4 times 2, that's 8. 8 minus 4, that's 4. So as you can conclude that this one is going to be an extreme value, but you don't know where it's going to be minimum or maximum. And then now we're going to go back and look at the r. And then when we look at the r, this r is greater than 4. So I'm going to say, since r, the one that we found here, r is greater than 0, sorry, r is greater than 0, since r is equal to 4, we're going to conclude that this point is a minimum point. And then we're going to find the minimum value when you plug this one back into the equation. Then you plug it into the equation, you're going to have your answer. Plug-in is very, very simple. You're going to have your answer -4 over 27, and this one is going to be your minimum value.